and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today we'll be talking to Lynn Gallagher and Ron Silberstein about malting barley for craft brewing. California has had a rich history of malting barley, but fungi and plant diseases have made it difficult to grow certain varieties in California's Central Valley. Lynn Gallagher, barley breeder extraordinaire, has spent the last 20 years working with the USDA, maltster Ron Silberstein, and other partners to fix this issue, breeding barleys at various levels of scale to find a robust, resistant barley for your favorite brews. We'll get to all this in a minute, but before we dive in, we wanted to give a quick shout out to our sponsor, Gazmat Technologies, the maker of the GT5000 Terra, the smallest portable FTIR multi-gas analyzer for greenhouse gas and environmental research. Measure carbon dioxide, carbon monoxide, methane, nitrous oxide, nitric oxide, nitrogen dioxide, ammonia, and water vapor in real time, simultaneously, from static or automated chambers. Visit www.gazmat.com, that's Gazmat spelled G-A-S-M-E-T, or email sales@gazmat.com for more information. I'm your host, Abby Morrison. Let's talk about science. Hi, everyone. Welcome to the show. Today we have Lynn and Ron with us. How are you guys doing today?
Fine. It's a clear day. No smoke.
Good. Great.
And I'm doing fine too. It's a little warm for my liking, but and I know in Davis you guys get the warm weather all the time, but we're doing great.
Yeah, great. We are having a nice blustery fall day in Wisconsin, so big fan of that. Yeah, so Ron, you are a founding member of the San Francisco Brewers Guild and a graduate from the inaugural class of the American Brewers Guild Craft Brewing Science and Engineering program. He's also a graduate of the Malt Academy at the Canadian Malting Barley Technical Centers. He opened Thirsty Bear Organic Brewery, San Francisco's oldest brewery restaurant, in 2007, and co-founded Admiral Maltings with Curtis Davenport and Dave McLean of Magnolia Brewing in Alameda Point, California in 2017. Lynn lived in Africa for 13 years, serving in the Peace Corps for 2 years in Tanzania, Mount Kilimanjaro, and 1 in Kenya at Turkana in the Rift Valley. He worked 2 years in Ethiopia for the University of Addis Ababa at the Debrecen Experiment Station during the Red Terror, followed by 8 years working for the University of Minnesota in Morocco, building a faculty of agriculture while breeding barley. He worked for the last 25 years breeding barley at the University of California, Davis. What a pleasure to have both of you on the show today. Super excited to get into it. So today we are talking about malting barleys and specifically this decades-long adventure on coming up with this new variety. So to get started here, can you give us some background on maybe like the history of malting barley in California, why you needed to have a new variety, some of the factors that went into that, and some of the parameters for success that you were looking for?
Well, barley had 4 market classes, one of which was malting barley. And I started to get interested in malting barley because there was a great deal of research money available, and there was very little research money available for the other 3 classes. So I started a breeding effort thinking that I could get a part of the pie, which was the grant money. And at the time, I wrote several grants for the university, applying for funds, and each time I got rejected because they said there was no malt house locally. And so I thought, well, it takes so many years to develop a malting barley that I would start by myself using the funds that I had for my other programs, that is feed barley, food barley, and forage barley. And so with initial money and my own money, I actually started over 20 years ago breeding for a malting barley. And so to achieve this objective, because we had no history of having germplasm in California, I exploited the programs in Oregon State and CIMMYT in Mexico. CIMMYT is an international organization with a barley mandate. It's now been moved to Akarda in Morocco. So I initially screened material from the Oregon State Malting Barley program with the disease resistance program from Mexico, and over a period of about 5 to 10 years, I identified interesting strains adapted to California and began making hybridizations and creating populations in which to select for superior malting barley. And so, how that worked is initially you start out with hundreds of samples from small rows, and you select agronomically in the field for grain yield and disease resistance. Each year, I would send about 100 samples to the USDA malt lab in Madison, Wisconsin, and get the results, and generally choose the next 2 or 3 lines to continue to amass data on. And then each year, new interesting strains would come up, and so that process would be repeated each year, sending samples to Wisconsin to be analyzed, and then bringing back the best ones and analyzing them in the field for disease resistance and grain yield. So usually that would go from small plots, 6-foot rows with half-pound samples, and then as you gather together very good ones, then you would analyze them in larger plots using 200-pound samples. And then eventually, if you found one that was really good, then you would want to analyze the data on a plant scale level using thousands of pounds from farmers' actual fields. So it goes from very small plots to larger plots to farmers' fields, and then into a plant scale where you need a malt house to evaluate the strains.
Great. And what in particular, traits-wise, you've mentioned kind of some disease resistance and stuff, but like what are you looking for that would be particularly useful for that Californian setting that would set it apart from other kinds of barley?
Well, there are 5 fungi which attack barley in California. I won't go into their names, but there are also 2 viruses. So it makes it very difficult for us to use barleys or introduce malting barleys from the northern Ontario states or Canada and grow them in the Central Valley because of the specificity of the diseases that we face, that we were required actually to create or build our own variety adapted locally. So the other thing is that we would look for very important characters such as malt extract, barley protein, plumpness, grain protein, and enzyme levels. Those were the characteristics that we would have measured by the USDA in Madison, Wisconsin. And so from the 100 samples we would send in each year, we would throw away maybe 95 of them and go on with the other 5, continue to evaluate. So over the years, because you would not see all the diseases you needed information on in 1 year, it would take several years to gather disease information so that you're accumulating enough data that people would accept the results. So the problem that I had was getting 1, research funds, 2, interacting with people and building a network of cooperators in Mexico and Oregon State, and then getting farmers involved. Getting farmers involved was extremely significant. And then after several years of working in that network, then Ron came on board with his malt house.
What's interesting about what Lynn said, and I'm sure he could add to this far more in depth than I can raise the point of, is that historically, barley has been grown in California. In fact, there's a landrace variety called Atlas that I believe the Spanish had brought over. And UC Davis, my understanding is that UC Davis back around 1900 until 1950, they first went, especially the first time, through about 200 different strains of this landrace variety Atlas that in theory came from the Atlas Mountains in Morocco, when they developed their very first malting barley registered seeds. But these were a 6-row variety, but it was a variety that was even exported back to England right up until World War II, and was the Hungry Hollow and Dunnigan Hills regions, which just surround UC Davis there, were known as prime barley growing country by the English on the London Barley Exchange. And they even called the barley that was grown out here sun-kissed, as if it were, because of Mediterranean climate, as if it were kissed by the sun. So maybe it was for funding at first, but Lynn was really building on quite a tradition. And of course, it's true, there were no malting facilities in California, or at least Northern California, when Lynn began this at the university. But there used to be quite a few, even in San Francisco. The last one closed about 1981, called Bauer and Schweitzer. That was on Chestnut Street in North Beach in San Francisco. Now it's condominiums, but some of the old silos are still there. So there's quite a history. And that actually, from that malting facility, Anchor first got its malt, as did Sierra Nevada, just in its first year or so, Sierra Nevada. But so, yeah, he built on quite a history.
It's very, very interesting that California was exporting barley to Scotland from the 1860s.
That's crazy.
And they were exporting a variety which was grown in England. And they stopped growing it in California when the demand in England, even from the own English variety, was discontinued. And so it went on using other varieties. But the thing is that because of the barley maturing in warm weather and being quite clean at harvest, they're having very few standards perhaps in the UK at that time. They found it extremely desirable. And it's a rather amazing story. But the whole thing sort of crashed in 1939 with World War II, that there was a tremendous decline in the export of barley to the UK.
Sure. So you're bringing it back. So good on both of you for doing that. So I think, and I know also, speaking of, sending things tremendous distances, obviously going over oceans being a bit farther, I know one of the reasons you guys wanted to do this was also just for the sake of brewers. It can be expensive to be shipping the materials that they actually need for brewing from other places. So maybe a bit of a callback there as well. But you mentioned earlier these kind of 3 tiers of scale. And so I wanted to talk about that a little bit more as far as how you did that. But I also, just for people, by which I mean myself, but also probably many listeners, I'm not familiar how you can go from barley to like finished product. So, Ron, would you be willing to, as the maltster here, kind of go over that process of how you go from the barley itself to a finished alcoholic product?
Absolutely. And anything that Lynn needs to fill in, he can. So the first thing is for any fermented product, we need yeast, a single-celled microorganism, and I guess it's a type of fungi, to consume sugars, and it will convert those sugars into parts CO2, parts ethanol, alcohol. It throws off a few esters and things, but primarily that's what the yeast does. So if you're going to make wine, I mean, you just step on a grape, you got the juice there, it's nice and sweet. The yeast can just go in there and eat away and feast on the sugars in the grape, or cider, but the yeast can just feast on these sugars in the apple. But in a barley seed, there's no sugars that the yeast can consume. They're bound up in protein matrices and cell walls, and they're starch granules, and they're very complex starch chains that go on and on and on. And so the goal here, what we want to do is we want to take the barley seed and we want to transform it into a source where inside that kernel is water-soluble sugars with enzymes to help the yeast to break those sugars down even more, but water-soluble sugars that the brewer or the distiller can extract and then ferment. So what we do, there's three basic steps in that. You take the seed, which has all this potential, all this energy. It's just not water soluble, and it's not available to be consumed by the yeast. So the first thing we do is basically we're tricking it into thinking it's going to grow a plant, because in that process, it's going to put out growth hormones like gibberellic acid. It's going to put out other enzymes to break down the cell walls. It's going to create enzymes, alpha and beta amylase, which will later on break down sugars so that the yeast can eat it. And to get all that goodness and in a water-soluble format, we soak it in water, we germinate it, and then we dry it in a kiln. And it takes a little longer than a week to do that. You do a couple days of soaking, maybe 4 or 5 days of germinating, and then maybe 24 hours of drying it in the kiln. And that final action, the drying of it in the kiln, not only stops the green malt from growing, so we do that at a very particular stage in the malting process where we can maximize the amount of enzymes that are available, maximize the amounts of sugars that are available, but we don't want much of that consumed into growing a plant. Obviously it's going to grow some rootlets and it's growing its first acrospire, but you don't want that first leaf, that first acrospire that's growing the length of the kernel. You don't want that to get too long or start to turn into a plant. So we dry it in a kiln to stop that germination process. It makes it stable so you can ship it and store it and do all that. We lower the moisture content from the green malt of about 46, 44% all the way down to under 5%, hopefully under 4% if you can kiln it well. But as important, or perhaps more important than anything, that's where a lot of the color and the flavor of the malt comes out. Of course, it starts with the soils that it was grown in. Of course, it starts with the variety. Of course, it starts with how vigorous it is and how well you steeped it in water to have a nice, vigorous germination. But at the end of the day, when you put it in the kiln there, we're going to take heat, really super high airflow. Our fan goes at 30,000 cubic feet a minute, but it runs over a heat exchange then, and we are going to with heat, with the amino acids that are a breakdown byproduct of the proteolysis, of the breaking down of the proteins, and with the sugars that also some of the enzymes have started to break down. Heat, amino acid, and sugar make for what's called a Maillard reaction. And it's just like what you get in your oven, from browning the skin on your chicken, or you're toasting a nice piece of whole wheat bread, and it gets that nice color, or you braise something in all of that is a type of Maillard reaction with amino acid, sugar, and heat, creating this beautiful plethora of color and flavor. And so that's the final step we do as a maltster. And aside from using this really nice variety that Lynn developed, uniquely suited for California, and beside growing it here in California, we're able to get, and I think this was the most unexpected aspect of what we're doing, because there just aren't many small maltsters, is that we can get the brewer or a distiller the product when it's fairly fresh out of the kiln. And for that, you just get all sorts of aromatics and volatiles that you otherwise wouldn't get from older malt that's 6 months, a year, 2 years old. And so people are just blown away at the freshness and those aromatics, but it's not that hard to understand. I mean, what's better, a loaf of bread out of the oven, or once it's been sitting on a shelf in a grocery store for a few weeks in a plastic bag? It's going to be much better right out of the oven. Same thing with freshly roasted coffee. The same thing with a lot of that type of food product or whatever. You really notice the flavors and the aromas. So that's another really unique attribute we can do. But it's just been fantastic being able to work with the person who develops the barley for characteristics you like, and be able to work with the farmer, and be able to work with the brewers and the distillers. The distillers, basically, all they do is they take the product that we the sweet liquid that you use, using warm water, which will activate the enzymes, and you draw out a sweet liquid from the malt. A brewer will boil that, add hops, and then ferment it. A distiller will just cool it down, add yeast, ferment it, and then distill it. They strip the water out of it until it becomes really 80 proof whiskey or 100 proof whiskey or something like that. But basically, whiskey is just distilled beer that doesn't have hops and all that in it. So that's what we've done with the product that Lynn develops. And the farmers depend on him a lot too, as far as having a crop that doesn't fall over or lodge, or a crop that isn't in a heavy dew or a late spring, early summer rain doesn't start sprouting on the stalk, what we call pre-harvest sprouting, or just all sorts of, it doesn't shatter. The breeder does also, and he has to make it disease resistant. That's why we weren't growing these North American varieties here, is because it's rolling the dice. You get lucky one year, and another year, kabam, it's wiped out. So we have much more, the farmers have much greater security because of the work Lynn did at UC Davis.
Great. Yeah. What a fun and unique opportunity. It's really fun to hear about it. I have an additional, go ahead.
Let me interject. It's very interesting because the plant story to the malt house, for the plant, it goes this way, that the plant is producing sugars. The sugar of transport is sucrose, but the sugars of storage are primarily glucose. And the glucose is organized in the seed as two forms of starches. One form is called amylopectin, and the other one is amylose. It's 80% amylopectin and 20% amylose. The amylose is just an arrangement of linear glucose molecules. The amylopectin is not just linear, but is branched. And the thing is that these sugars are stored as starches. Ron gets a hold of the starches, and he converts them back to sugars. And the sugar that he primarily ends up with is called maltose.
Right.
Okay. All right.
It is fascinating because we've got this incredible storage facility inside the seed, but the brewers and the distill, can't access that sugar like they can the fruit product or something like that. And so we malt it. And I loved how Lynn just explained, that the sucrose is the transport, but we have it in really long-chained, the mylopectins and the amylose, long-chained starches. And the maltster will start breaking those down. But the maltster also creates enzymes that break those down further in the mash tun. So that's where a lot of the breakdowns into the maltose, multitriose, start happening. So, anyways, it is fun stuff.
Yeah, very nitty gritty. So kudos to you both for diving so deep. Hi everyone, I hope you're enjoying the show. Interested in learning more? Lynn and Ron's article, Registration of Butta-12, a 2-row malting barley adapted to the California Central Valley with proven floor malting success and craft brewer acceptance, published in the Journal of Plant Registrations, will be freely available for the next 2 weeks. You can find a link to it in our show notes. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thanks again also to our sponsor, Gazmat Technologies. Conduct greenhouse gas flux measurements in the field using the GT5000 Terra. Weighing 20.7 pounds, splash-proof IP54 rated, internal pump and battery, and vibration resistant, the GT5000 Terra is a robust and portable multi-gas analyzer for fieldwork. Visit www.gazmat.com or email sales@gazmat.com for more information. Thank you for being our sponsor. Let's get back to the show. I have one more clarifying question. So when you are talking about malt, is that like ground up barley grain then that has been kind of toasted in this kiln process? Is it the sugary liquid from kind of mixing it with hot water? What exactly like is malt? And also subsequent question, is this the same kind of malt as like a malted milk ball? Or is that just like a different thing entirely?
All right. So to answer your second question, yeah, malted milk ball comes from malt. Absolutely. There's a different process to extract it. And I don't know much about it. I think there's even some freeze dried process that goes in to create that kind of sugary thing. But yes, malt comes from malt. Now, you can malt any grain. You can malt wheat. You can malt rye. We malt wheat, rye, oats, and barley are the main ones we do. If you eat grape nuts in the morning, that's malted wheat and malted barley. It's really sweet, it's really crunchy, it's really great. But we do not grind it up. The brewer will grind it up. Not too fine. They want to, there's other reasons for that. It depends on the style of brewing they're doing. But most brewers who do what's called infusion mashing, where you soak the malted barley at one temperature and then extract the water from that, they grind it fairly coarse, and it's got a lot of the husk material and the husk material of the barley in there. It almost acts as a filtration bed. But so, no, when we're finished malting, we have a little seed, and it's been dried in the kiln. It has these little rootlets, and they're called culms, C-U-L-M-S. And we have to decalm it or have a rootlet remover remove the rootlets. We shake it down, we clean it so there's no broken kernel, skin kernels, chafe and dust and that thing. So it's just that. And then we put in a bag. It could be put into a super sack, which is a 1-ton bag, as opposed to a 55-pound bag. It could be loaded into a hopper truck and transported to a facility where it's loaded into a silo. But then the brewer or distiller will take that malt, and some distillers will hammer mill that into a fine flour. They have different types of equipment to do that, and they often use some exogenous enzymes where they'll add additional enzymes in addition to what the malt may have. Some brewers will grind it fairly coarse, and so there's a range depending on your method of production and how you're going to grind that. But it kind of looks almost identical to the seed because it just started to grow little rootlets in an acrospire, and you can still see the acrospire in there underneath the husk, but the rootlets we take off. So the sweet liquid is afterwards, and that's called the wort, W-O-R-T. And that's like it's like the juice that you make wine, wine's made. It's like the grape juice there, the mosto or whatever they call it.
Okay. All right. Okay. That helps clarify things for me. Also just astonished at the scale of just like a 1-ton bag of seed is just wild. So congrats on that. So speaking of scale, so you had basically Lynn started by breeding for kind of more the agronomic traits like the disease resistance. So then you were also starting to look at kind of these malting characteristics at a very small scale and then a larger scale and then kind of that plant scale. So what did you find? What were you figuring out at each of those stages?
The USDA has established standards for what makes a malting barley acceptable. And we might think that some private companies have their own standards, which are quite similar. But the USDA, they weigh the kernels, they screen them by sieving them, and by sieving them, they establish the plumpness, they evaluate barley color, they evaluate the percentage of malt extract, they look at the wort color. The wort, remember, is like a soup. They look for wort clarity. They look at barley protein. They look at wort protein. They look at soluble versus total protein. They measure something called diastatic power, which is primarily beta amylase, an enzyme. And then they look at the most important enzyme, alpha amylase. Then they look at beta glucan, which one can think of as fiber, which is very important during the filtration process. And then they look at free amino nitrogen. So the problem is that you're running into the Goldilocks problem. The porridge has to be just right. And the majority of them fail. Okay? Each year we're getting back maybe the best 5 or 10 that we look at for the next year, and we evaluate those for disease and agronomic characteristics. And it just goes on and on and on. Each year it goes back to the field to be evaluated in the field. Then it goes back to the USDA. And in the meantime, we have a backup of thousands and thousands of strains that we want to have analyzed both in the field and in the USDA malt lab. So it's an iterative process. Goes back and forth, field lab, field lab, field lab. Every year the same thing.
And at the lab, they're really only malting, literally it's measured in grams, or maybe, I don't even know if they ever use 500 grams, but they use a fairly small amount to do this. And it's really just for scientific purposes, because a lot of those specs or a lot of those measurements that they've done analysis on are really key indicators for a brewer. I'll just go through sort of some generalized things. In general, we like lower protein barley. That's really hard. You have to watch. It's not just varietal dependent, as in does it tend to make a lot of protein, but it's how much nitrogen the farmer is going to put in the soil. But it's really important to have lower proteins because the brewer wants extract to ferment. They want more extract and less proteins. On the other hand, the proteins are important to some degree. You need them because you're going to get your amino acids that create your enzymes, and you're going to get better enzymatic with the higher proteins. You'll have better enzymes. You don't want, for example, too many beta glucans, just as far as the filtration and the clarity of the beer. You want enough proteins also in there for the free amino nitrogens, because that's food for the yeast. And they're even doing studies about which amino acids certain yeasts prefer, or prefer different varieties of barley. And then the soluble proteins over total proteins, again, go to what might cause instability in the beer, or what might give it good head, foam retention. So there's all of these attributes a brewer can look to them and go, oh, and they will plan their recipes based on some of this stuff. You've got to know how much extract is available to plan a recipe, to know what sort of alcohol you're going to get. And so some of these things are critical for the brewer, and the enzymes are absolutely critical, because if you're doing an all malt mash with no exterior enzymes, exogenous enzymes added, then you have to have sufficient enzymes, both the alpha amylase, like Lynn pointed out, and the diastatic power, which is primarily beta amylase. You have to see what is in there to know whether you're going to have enough enzymes to make a good beer. So we do that on a much bigger level, and the reason is because now we've got to make the beer. We need to taste it. What are the flavors? Does it just make lousy beer? Does it just not perform well in the malt house in a non-lab setting, but in a setting that's a plant size? We had one barley from UC Davis that seemed very promising, and it was really fat. They loved it because it was so fat, but it was so fat we couldn't hydrate it properly. And if you can't hydrate it properly, then you can't germinate it well. And if you can't germinate it well, everything goes downhill from there. So something that is a good attribute in smaller amounts isn't in great amounts, and that's that Goldilocks problem. You don't want something that'll sprout on the stalk. On the other hand, if you have to wait a year before you can malt that barley, that's not necessarily good for the maltster either. And we notice, that for example, the barley that we use now has a slight dormancy. It's much more vigorous after it's been able to sit for a while, even though it has the capacity to germinate right away. So these are all things we're doing, and we're able to do that. We're able to let someone brew on a big scale and just taste that beer, taste that whiskey. What's it like? How does it compare? So yeah, that's where we come in after the lab results. But without those lab results, we don't know what to focus on.
Sure.
So,
Yeah, of course.
So that's very interesting because the brewers play all sorts of games with additives. For example, a big company like Anheuser-Busch uses rice, but local craft brewers can use other things like blueberries or blackberries or oats, and all of these additives can modify the tastes. And believe me, some of them are outstanding. You have to focus on the individual ability to taste. Genetically, we're all different, and we all like different wines. We like different beers. I like stouts and porters, and I like them aged in whiskey barrels. But that's just me. Ron probably likes something else. He can tell us about that.
Yeah, it's funny nowadays. Now that I've been making malt, I actually have gone from a big lover of IPAs and I always did like the English ales, English bitters, cask conditioned ales, that sort of thing. But I'm really enjoying the good, clean pilsners, made where it just focuses, it just highlights this malt, and in very delicate, subtle ways. And there's some real nice beers that are coming out, even commercially, using the barley that Lynn developed and we malt. You could go out and buy some at Safeway. You can go there and get Seismic has an alluvium pilsner, which is made 100% from this Butta-12 that Lynn developed, and Hen House, these are all local breweries up here near Santa Rosa. They have a oyster stout. They use our malt in, and they're gonna. So it's really fun to start to see something that started, with Lynn messing around with barley varieties and grabbing money from one program to do this for another, just with a vision, but without any malt houses here. I could go on and on. I'm looking at a wall here in my library where I've just been collecting cans that people are putting out that have been with our malt. And we actually named one of our malts after Lynn. It's our most popular pale ale style malt. We call it Gallagher's Best. And we've had people call their beers Gallagher's Best. I don't think Lynn sued any of them for copyright infringement yet. But
great.
It's fun.
Yeah.
Come local.
Yeah, what a fun way to channel a creative spirit. That's, I guess, creative spirit in both the alcoholic sense and as a person.
Right.
So I've got 3 questions left for you guys. The first one is, if listeners want to learn more about any of the stuff that we've been talking about today, where can they go for more information?
Okay, let me start. You can go to the ICARDA website, ICARDA. They have the international mandate for barley breeding. The other place you can go is the CIMMYT website in Mexico. That's CIMMYT, and both of those are .orgs, but they're very interesting. You can also go to the Breeze Malting Barley site, which is also full of information about brewing. Ron?
Yeah, those are great ones. For just in general about the craft malt movement, there's a North American Craft Maltsters Guild. Google North American Craft Maltsters, MALTSTERS Guild. That's a nice resource. To a lesser degree, the Brewers Association will have some stuff on malt and all that. Definitely, you can go to our website, Admiral Maltings, MALTINGS.com, and you could come visit the malt house. We'll give you a tour of the malt house. You can see how malt is made from these different grains. Those would be some good places to start with. There is a book on malt that the Brewers Association put out.
Sure, we'll put a link to that in the show notes.
One other would be AMBA Inc., the American Malting Barley Association.
Yes.
I forgot to mention them, but they also have a website, and it's AMBA, AMBAINC.org, I believe, or com. I'm not sure.
Great. We'll put a link in the show notes for that one too. Yeah, those are some excellent resources to tap into. And then second question is if people want to get involved, then take that next further step. It could be getting into microbrewing. It could be getting involved with plant breeding. Any of those things.
Plant breeding is a very, very expensive operation, but I would suggest that they go to Ron and buy those home brewing kits that he has.
We do sell small amounts of malt to home brewers. They can buy a whole bag, a 55-pound bag, but we do also we have a malt house pub. I don't know of any other place in the world really like this, but you can sit in the pub and, well, right now you can't because it's closed down because of the pandemic, but you can look over the malt house floor and literally watch us germinate the barley, etc. And so it's really exciting. And we have over 20 taps there of all sorts of different beers made by commercial brewers, mostly in California, both northern and southern California. And so you can try beers and you can try spirits there too, like from 117 West or Workhorse Rye, just different spirit makers. And some people I've been tasting some spirits lately that's still in the barrels as far as aging, because they like to age a few years and we've just been open a few years. So they could come to the pub and check that out. They can come and check out the beers. They can get into home brewing. And there is an American Home Brewers Association. I think that's a sub-branch of the Brewers Association. They can probably try and volunteer at UC Davis in the plant science department. I don't know. Maybe they need some sturdy backs and strong arms to help them with some of the growing. But I don't know about that. That's probably more complicated. But certainly brewing, home brewing, visiting your local breweries, supporting the people who support their local communities. I mean, one thing that Lynn has reinvented is to allow local farmers to grow a locally developed barley that they can sell locally to their maltster, which can then be brewed and distilled locally. It's just a huge impact on the economy when you count up the transportation and the repairs and the maintenance and the packaging and the energy and the transportation and the storage and the fixing the machineries, all this kind of stuff. You're keeping your money in the community and you're keeping the carbon footprint small. You're not importing malt that was grown in England or Germany or even Canada. So those are all good reasons to support your local brewery, local maltster, local distiller, and your local agricultural college.
Great. All right. One final question for you guys today. What is one fun fact that listeners would not know about you if all they had was your research?
Well, I guess I'll go first. I have digitized my photographs taken 50 years ago from the days of the Peace Corps, and I have digitized them and put them on my Facebook page.
I'm going to go look at those. I don't go on Facebook a lot, but I will now. Oh, I don't know. I have twin boys who are 18 years old and a little 5-year-old girl. So I have a family. I love just keeping active. I like to run and swim and hike, and I play a little guitar. So I'm not very good though. You wouldn't want to listen to me play, but it's fun for me.
Well, wonderful. What a plethora of fun facts. It has been such a delight to have you both on the show. I have learned a lot. So I'm really happy about that. And thank you for coming on.
Thank you very much, Abby.
Thank you, Abby.
Thank you for listening to Field Lab Earth. You'll find a link to today's paper and other resources for this episode in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe and don't forget to rate and review us on Apple Podcasts, Podchaser, Stitcher, or anywhere else you find your podcast if you like our show. We are also available on Lyceum, the world's first audio learning community, where you can join our discussion group and comment on each episode. This podcast is a joint production of the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by authors are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.